be covering today, like what are the general outlines, I think this is an important concept. So how does a building analyst become an environmentalist? It's through running combustion safety tests. It's knowing that every time you're running a combustion safety test, you're ensuring that CO, CO2, NOx, soot, smoke, all of those things are leaving the home. And you need them to leave the home because otherwise they would destroy the homes, they would destroy people's respiratory systems. It'd be catastrophic if homes didn't have chimneys and were powered by fossil fuels. So a building analyst becomes an environmentalist knowing that we are burning these things, they are harmful, and we do have a big problem when we have 7.7 billion people on the planet who are trying to make those exact same choices. But we have passed a tipping point. There's shared global concerns that we've blown past what's normal, and we're marching towards uncertainty. How does a building scientist become an environmentalist? There's this really elegant formula. And if anyone has a copy of Residential Energy, it's right there, and all modeling software is based off of this. You just take the insulation levels, more or less, you multiply it by the exterior surface area, and then you multiply it by the difference in temperature between inside and outside all year long. And when you do that, you learn how much heat is lost through conduction through that building over the course of the year. But what's interesting right now is everything about that is changing. So right now, energy code, as Beverly was talking about, keeps getting better and better and better and better and better. However, at the same time, our homes are still getting bigger and bigger and bigger and bigger, and then our planet is still getting warmer and warmer and warmer. When you go and you sit down and you try and do the math and figure out how much a home is going to be using energy, everything about that has changed or is changing. So that's part one of the equation, and what you end up with is a number, is like a millions of BTU number, and then you're on to the next step. So you know that a home is going to need nearly 100 million BTUs over the course of the year. Now your next question is, how am I going to generate that heat? And so you go and you figure out the cost of all the fuels, you figure out the BTUs per unit, the efficiency of all these systems, and then once you have all that information, you can figure out the operating costs using today's utility prices, and then you can also figure out how much carbon emissions that each one of these fuels have. And this is not something that's easy to take in, so I made a chart so it's a little bit easier. If you look over here, you see, wow, natural gas is cheap in Massachusetts. It's cheap today, but when you go and you look at the carbon emissions of natural gas, so over on the right-hand side, you see that it's not that much different than propane. It's definitely better than home heating oil, but not that much. And then you look at the peak, you have electric resistance, and that's just using a toaster oven more or less to heat your home. It's expensive and it's not clean. However, we're here today to focus on those two technologies on the right as great solutions to heat your home. With air source heat pumps today in Massachusetts, they are cost competitive to run to natural gas, and the carbon emissions are about 40% less. With geothermal, it's the cheapest, cleanest way to heat and cool your home, but it's priced competitively with all of these rebates in Massachusetts, federal tax credits. We have alternative energy credits, and those are huge in changing the way that these technologies become affordable for Massachusetts homeowners. So earlier I talked briefly with reviewing all the technologies, and I said that $4 a watt changes everything. So with $4 a watt, it enables air source heat pumps, ground source heat pumps, to be significantly cheaper, literally a fraction of the cost of what it would be to heat your home in natural gas. You have zero emissions. There's no reason not to be adopting these technologies in your next project. So how does a father and a husband become an environmentalist? That's where I live, right down the street, and I used to work in that building over there. It wasn't a tornado, it wasn't a hurricane, it wasn't nor'easter, but it was a wake-up call. This was February of last year. And I know that some people in the room may be thinking that I'm confusing weather and climate, and it's not the same thing, and I know it. But with Climate Ready Boston for 2050, it has exactly what's going to be happening in my neighborhood. My house will be underwater 10% of the time in high tide. It's just not a good story. So climate change is personal. That's my story. I got one more slide, and it has a little bit about being a father in some ways. There's like two different ways of thinking about like raising or modeling your children. I'm sure there's more than two different ways, but one's being a carpenter, and that's building it for them. So that's making sure they read the right books, get in the right school. The other one is being a gardener. This style is all about creating a rich, diverse, dynamic ecosystem. So earlier we said with the goal of the training today, the goal was to get all of you guys on the exact same page about like affordability and things around that nature, but I'm gonna adjust it a little bit. So today the goal is to learn, share, and meet other like-minded practitioners. Our goal is to surround you with memorable, quality information being delivered by people that you can trust. We hope today leads you down an exciting new path. Thank you so much, everyone.